Hello everyone, welcome to this session. In this session, I will explain error function and its mathematical form and its implementation in Python code. The error function is often denoted as ERF of x. It is a special function in mathematics, particularly in probability and statistics, that calculates the integral of a Gaussian function from 0 to a given value. It is closely related to the normal distribution and helps determine the probability of a random variable falling within a specific range. The error function ERF of x is defined by the integral ERF of x integration 0 to x 2 divided by root pi e to the power minus t square dt. It is also known as the Gaussian error function. It is an odd function, meaning ERF of minus x is equal to minus ERF of x. Okay, here I have plotted the error function from minus 3 domain to plus 3 domain. From seeing the graph, you say that this is an odd function. Okay, the key application of the error function is in probability and statistics. It is essential for calculating probabilities associated with normal distributions, including determining p-values, confidence intervals, and critical values. And it has application in partial differential equations also. It arises in solutions to the heat equation and other related problems. Okay, here I have written a numerical problem based on error function and Simpson's one-third rule. So the question says that using Simpson's one-third rule, compute the integral 0 to x of the error function ERF of x is equal to exponential of minus t square. For x in range, the range is given is minus 3 to plus 3. Plot ERF of x against x in the given range with the rectangular grid, and also draw x-axis and y-axis and put a suitable title and axis labels. I will solve this question using Python code and I will show you the code next. This is the Python code. As usual, at first I have import some packages. First import numpy as np. I import this numpy package to define the function and to define the x domain. And next I have import matplotlib.pyplot as plt for plotting this function. Next I define the function which have to integrate. def f of t. Here def the keyword and I have taken the function name as if, and here t is a variable, and return np.exponential of minus t square. Next I have defined Simpson's one-third rule. Def is the keyword and Simpson's rule I have taken as function name as Simpson's rule, and then bracket if a comma b comma n, this is the argument, and h is equal to b minus a divided by n. Here n is the subintervals and b is the upper limit and a is lower limit, and I have taken x is equal to np dot linspace, that means line space, a comma b comma n plus 1. Here a is the lower limit, b is upper limit, and n plus 1 is the number of points between a and b. Here I have taken y is equal to f of x and then return h by 3 into y 0. That means the first element plus y minus 1, that means this is the last element, and plus 4 star np dot sum y 1 colon minus 1 colon 2. That means this is 4 into the sum of the odd values of the functions and plus 2 into np dot sum y 2 colon minus 1 colon 2, and that means 2 into sum of the even functions. Okay, here I have defined the error function, that is def erf. Here I have taken the name of the function as erf. Okay, and x and def erf bracket x comma n equals to 100. This is the argument, and return the error function, that is 2 divided by square root of pi into Simpson's rule, that is um, I have said earlier, that is this is the function Simpson's rule f comma 0 comma x comma n. This is the argument, and then generate x values in range minus 3 to plus 3. It is written as x is equal to np dot linspace minus 3 to plus 3 comma 100. Here minus 3 is the lower limit and plus 3 is the upper limit, and 100 is the number of points in between minus 3 to plus 3. And then I have calculated the error function for each value of x, that is erf values is equal to np dot array bracket erf xi if xi greater than equals to 0, else minus erf of minus xi for xi in x. In this way I have calculated the error function, and then I have plotted the error function plt dot plot erf x comma erf x values, and then plt dot x label x, plt dot y label erf of x, and the title is error function, and plt dot grid for the rectangular grid, and plt dot show for showing the value. Then I run this code. Please wait a minute. And this is the plot of the error function. Okay, I think this is clear to you. Thanks for watching this video.